on to problem number 9. We're talking about silver tarnishing. I actually printed out, look at that, magic. I know in other videos, people would actually be able to show you, I don't know, some kind of screen or a split screen. But yeah, Mrs. Farmer just prints it out to use it as clip art on top of her problem. But anyways, the idea is we have spoons that are made out of silver that if they're exposed to the air for too long, because the amount of sulfur or hydrogen sulfide, I should say, that is in the air just normally occurring, they will eventually get this grayish black look on them, and that would be considered tarnish. In our equation here, we're talking about pure silver that is exposed to that hydrogen sulfide and oxygen, which is normally in the air, and eventually we get a reaction of silver sulfide, which is the tarnish, and H2O, a liquid, okay? They give us information. It says usually H2S is the limiting reactant, meaning there's not a lot in the atmosphere. If a silver spoon is placed in a container that contains or that holds 56.7 milliliters of H2S at 1.23 atm at 22 degrees Celsius, how many grams of silver on the spoon will tarnish? Okay, so sorry, moved it around there for you. Are we comparing two gases? No. Or, for the combo, like it went through a change, is there a partial pressure or a mole fraction here? No. Which it makes sense. We're on to problems numbers 8, 9, and 10. It's going to be the last formula in the book just because of the order. So that means we need to use the PV is equal to nRT. I already, as I was reading the problem earlier, before I showed the video, I wrote down the things we know. It told me I have this amount of volume, this pressure value, and this temperature. All right, so once again, the magic of the folded paper, I put these all down. Now, do any of these give us a value of grams? No, because this is all talking about that unit. So we need to go through, first find our mole amount, because then we can go from moles of this to moles of our silver, and then get grams of silver. So a little stoichiometry there in the end. So let's go ahead, and since we're solving for the n, we're going to rearrange our formula. So we're going to get n is equal to PV divided by RT. Oops. Okay. And as we plug in our values, we have 1.23 atms. And when it comes to our volume, back here, remember, we are going to have to divide by 1,000 so we can get it into liters, because the unit has to be in liters. So we can plug that in over here. Not losing any of our significant digits, just moving our decimal place. And then we know what our constant is. Remember, those units with the constant will always let you know what units all your other variables have to be in here. So liters, atms, moles, and Kelvin. All right, and so then when it comes to our temperature, we have our 22 plus our 273, and that should give us 295, hopefully 789, yes, Kelvin. So we're going to plug that in right here. Okay, going through and solving that, you're going to end up getting a value of pretty small. And looking at this, we all can have 3 sig figs. Yes, because 3, 3, 3, 3. All right, so that is our mole amount of our H2S, which is great. But remember, we want an answer in grams, so we need to go through some stoichiometry, which I'm going to hopefully give us some space down here. Start off with our 0, 0, 2, 8. Oops, that's supposed to be an 8. Sorry there, folks. 8 moles of H2S. We want to multiply that by something so we can have moles of H2S cancel out, and we can get moles of silver on the top. Okay? So, where do I find numbers to be able to go from moles of one substance to moles of the other? I'm going to have this saying in your head so bad that you're going to have nightmares over it, okay? When we're going from moles to moles, we always go back and look at our equation. So we have 2 moles of H2S happening in this one. That's like a recipe. This is the recipe. So we know if we need to double it or half it, we can go. So if we have 2 moles of this, we must have 4 moles of silver. Okay, see that our moles of H2S cancel out. But we don't want a final answer in moles of silver. Remember, way up here, they asked for the answer in grams. How many grams of silver? So we go through, we make sure our moles of silver cancel out, so that has to go on the bottom of the fraction. And if you look on your periodic table, remember, when if you go from moles to grams, you must look at the periodic chart. In this one, it's easy. You're just adding in 1 of silver, so it's the 107.9. Go through and start off with our 0.00288 times 4 divided by 2 times 107.9, and we should get an answer. It looks like we can have still 3 sig figs of 0.622 grams of silver. Okay, when we're considering the point values for this one, I had it be that you had 1 point for getting all your units in the correct form, like the milliliters to liters and temperature to the correct way. 1 point for solving for your mole amount, and then 1 point for doing the stoichiometry. So altogether, this one is worth 3 points. I'm using different colored highlighter just to make it exciting. All right, 3 points for number 9.